All right, hopefully these are notes that everybody's got pulled up. We're in Algebra 1, Lesson 19. We're actually going to cover two lessons today, 19 and 20. So listen up, take notes, take part. Solving one-step equations by adding or subtracting, okay? This shouldn't be overly complicated stuff, but it might be stuff that you're new to, okay? I'm trying to learn that just because I've done this in other classes doesn't mean that it's not new information to you or that you're good at it. Do you need some tape? Yeah? Okay. You can put your book back together. Thank you. All right, an equation is a statement that uses an equal sign to show that two quantities are equal to each other. Is that basic information? Right? X equals 4 is an equation. It's got an equal sign in the middle. It shows me that two sides of this are equal to each other. They're the same thing. They have the same value. Okay? A solution of an equation in one variable is a value of the variable that makes that equation true. Okay? So 2x equals 4, right? The solution to that equation is x equals 2 because 2 times 2 equals 4. It makes the equation true. Does that make sense? That's just a simple one variable equation. Here. That's a mess. All right? Try to get like a long, I feel like this is weird because I'm recording this at the same time. Okay? So this is on YouTube now. So and then go back through and do the back. Do it nice, long strip instead of these little, looks like you've done stitches. Okay? All right, let's get back to our lesson here. Equivalent equations. Equivalent equations have the same solution set. Right? Where I have more than one equation that have the same solution. By adding or subtracting the same quantity from both sides of an equation, each equation remains equivalent to the original equation. Furthermore, each side of the equation remains balanced as the equation is solved. Both sides have to remain balanced. All right. For instance, if I see something, let's see, I'm trying to make something up on the fly here. But let's say we've got x plus 5 equals 3. All right. In order for me to solve for x, I have to balance the equation as I go, but I have to isolate the x. I have to isolate the variable. How many of you are familiar with this process? All right. In order to isolate the variable, though, I have to undo the operation that exists with the variable. Okay? So what I'm seeing with the variable is addition, right? The 5 is being added to it. So the only way to undo addition is through what? Subtraction. But I can't just do it to one side. Okay? I can't just subtract 5 from x, right, and just do that to the left-hand side. I also have to do it to the right-hand side in order for the equation to remain balanced. Does that make sense? All right, so whenever I start asking you guys these questions and you say, well, subtract 5, what I want to hear from you is subtract 5 from both sides. Okay? Now, you may mean that, right, when you say subtract 5, but I want to hear the entire statement, subtract 5 from both sides. I want you to be in the habit of subtracting from both sides or adding to both sides or multiplying to both sides or dividing from both sides. So what I want you to understand is that what is the opposite of addition? What is the opposite of subtraction? Addition. What's the opposite of multiplication? Division. All right, what's the opposite of division? Multiplication. And so let's just real quick, I'm going to show you, all right, here we would use subtraction, correct? The subtraction property of equality. If I change this just a little bit, right, where I make this x minus 5 equals 3, what property are you going to use? Right, if the other one we used the subtraction property of equality, this one we're going to use the addition property of equality. We're going to add 5, we're going to, not negative 5, we're going to add 5 to both sides. All right, let's get into habit. Let's say it again. We're going to do what? 5 to both sides. Okay, let's change it up a little bit. All right, so here we would add 5 here, we'd add 5 here. All right, what if it was 5x equals 3? What is happening with the 5 and the x? What operation exists there? Multiplication. How do I undo multiplication? Division. So I'm going to divide by 5 on both sides. So I'm going to divide by 5, x equals 3/5. What if it is something like this. All right, because it's division, in order to undo division, I'm going to by on both sides. All right, so I'm going to multiply by 5 here and multiply by 5 here. X equals 15. Do we get that? How many of you have we done this before? All right, good, good. All right, so we're still dealing in, hopefully, some old territory. So this is just an example of the addition and subtraction properties of equality hold for every real number a, b, and c. Here we see the addition property of equality. I don't know that these examples are any better than the ones that I just gave you. You see subtraction, okay? And we'd also see, and I don't guess that they deal with it today, but or at least they don't put it in the table, and I don't know why they don't put it in the table, but inverse operations. And we've already just covered that, right? Inverse operations are operations that are opposite of other operations. And you see that here. Addition and subtraction are opposites. Multiplication and division are opposites. We understand that. We can move on with our life. Okay? Now we get into lesson 20. Now, this may or may not be new information. Again, I don't know, but we're going to deal with it like it's new, or at least I am, which is graphing things on a coordinate plane. How many of us are familiar with coordinate planes? X and Y axes, all that kind of stuff. Quadrant 1, quadrant 2, quadrant 3, quadrant 4. Good. It makes two perpendicular number lines, one horizontal, one vertical, and they work like that. If you go up on the y-axis, you're positive. You go down on the y-axis, you're negative. You go to the right on the x-axis, you're positive. You go to the left on the x-axis, you're negative. You have so an x-axis and a y-axis. The y-axis goes up and down. The x-axis goes across from left to right. Okay, we need to know where our axes are. Tiffany, are you awake? Okay, follow along with me. I know maybe you've already got this and you know exactly what I'm talking about and you're bored. I hope not. I can't make it much more exciting, right? It's not a Marvel movie, but it's stuff that we want to know. All right, so the number lines end up dividing all of our information into 4 quadrants, numbered and named as shown. The intersection of the x and y axis is called the origin. It exists right here where they cross. The coordinates for the origin are what? Does anybody know? 0, 0. Okay? And hopefully you guys know how to write coordinates. Right? If I'm going to write a coordinate pair, what goes on the left inside that coordinate pair notation? X, my x value. That's how far to the left or right I am on the x-axis. What about on my other side? Y. Okay, that's how far up or down I am on the y-axis. Correct? Yes. Yep. Yep. All right. Now, the reason I asked that question is not to treat you like you're a little kid, but because I have kids that are in geometry class, I've got kids that are sometimes in Algebra 3 or Algebra 2 that still get this wrong. Okay? So, I'm not guaranteeing myself that you guys know how to write a coordinate pair. Okay? Because I still have kids in further classes that still mess this up. So, you need to know that it goes X, then Y. Okay? Left, right, then up, down. All right, so that's what this information is talking about. If you know this, great. If you don't, we'll go ahead and address it. But an ordered pair is written as follows: X, then Y. The ordered pair that represents the origin is 0, 0 because we're not left or right at all. We're not up or down at all. We're right there in the middle is my origin. So the first number in an ordered pair is our X coordinate. It indicates the distance to the right or left of the origin. The second number is the Y coordinate. It's the distance above or below the horizontal axis. A coordinate is a number that helps locate a point on a graph. So by saying something along the lines of, somebody give me a number, it could be positive or negative, 5, and what, give me something else, 3. All right, that tells me I'm going to go first where? If I was going to plot that, I'm going to go to the right 5, and then what? Up 3, right? And then I'm going to plot that point on my coordinate plane. All right, are all coordinates, are they always integers? No. Right? Integers are like -5, -4, -3, -2, -1, 0, 1, 2, 3, 4, 5, right? So those types of things. Can I get fractions? Yeah. right? I can even get irrational numbers, right? I could plot, a 3.14159 somewhere will fit on a coordinate plane. So coordinates can be made up of any rational numbers. In fact, by Algebra 3, we start plotting irrational numbers as well, to a degree. Okay, it's a little complicated. We won't have to worry about that today. All right, to find or graph a point, always start at the origin, then use the sign of the coordinate to determine the location of the point. Okay, start with your x, then move on to your y. This kind of gives you an idea of, with positives and negatives, which coordinate they're going to show up in, or which quadrant. I'm sorry. If I've got plus plus, they're both the x and y are positive. I'm going to be in the right or the top right quadrant, right? If my x is negative and my y is positive, I'm going to be in the second quadrant. If both are negative, I'm going to be in the third quadrant, down and to the left. If my x is positive but my y is negative, I'm going to be down and to the right. All right. Are we familiar with quadrant numbers? Okay. It goes counterclockwise from top right around. So this is 1, 2, 3, and 4. Okay. You need to be familiar with that. Okay. And there's a reason for this, because this is how we start looking at future things like algebra 2, geometry, algebra 3. We'll start talking about vector notation, polar coordinates, rectangular coordinates, stuff that's beyond where you guys are at and probably where you'll be, but you need to know this and that it's going to work that way. Okay, when there's a relationship between two variable quantities, one variable is the independent variable, the other is the dependent variable, and this is how we plot information on a table, right? When it comes to this information, I don't know if we've talked about this or not, because I get lost in all the different math that I've got to do in a day. But in terms of x's and y's, x is my input, y is my output, right? So when we have about 3 phrases that get used that all mean the same thing. For instance, domain, x values, and inputs, inputs, and let's see, independent variable. Okay, these all mean the same thing. They're all talking about x values, okay, because that's what I'm inputting, right? That's usually my equation, has an x and I'm solving for y. That sounded like it hurt. All right. Over here, we have range. If I can spell. And this stuff isn't in your lesson, so I'm giving you some extra stuff. Y values, outputs, and dependent variables. So if I'm giving you extra information, what should you do? Because you're not going to find this in your notes. Dependent variables. Do you think you might want to find a place to write it down? Maybe. All right, so range as opposed to domain, y values as opposed to x values, outputs as opposed to inputs, dependent variables as opposed to independent variables. All right, they're talking about independent variables here, the variable whose value can be chosen. We can pick a value for it, okay, is my input. The dependent variable is a variable whose value is determined by the input value of another variable, also called the output variable. For instance, are we familiar with slope-intercept form? Okay, so it's y equals mx plus b, right? So if they tell me something along the lines of y equals, let's say 3x plus 7, right? X is my independent variable, which means I can put in anything I want for x, okay? But y is wholly dependent upon what I put in for x. You follow me? Yeah. So I can make a table of values there, and I can start x is 0, x is 1, x is 2, x is 3, x is 4, but y depends upon what I put in for that x value. Okay? It is dependent upon what I do with x. Do we understand the difference between independent and dependent variables? Okay? For instance, in later math subjects and things like that, we'll look at a table of values and it'll have things like give you a table of values where it corresponds to somebody's age and somebody's height. Okay? And you have to decide which is the domain, which is the range, which is the x value, what is the y value. It doesn't tell you. All right? So you have to think about this for a second, and which is dependent upon what? Does your height determine your age? No. Right? Your height, I mean, if you're taller, you're not suddenly older, are you? No. But what happens as you get older? Really? Now, that may happen past a certain point, and I admit that it's not a perfect analogy, but when you were a baby, you were probably 20-some inches long. By the time you turned 1, you were what, 15 inches long? Did you get bigger? Taller? What happened as you got older? Right. But your parents didn't determine that you're now 1 year old because you're now 30 inches, right? He gets to 30 inches now he's 1, right? That's not how we determine that. So your height depends upon your age. Your age does not depend upon your height. Do you see which one is dependent and which one is independent? Okay? So that's how the real world kind of works inside an input-output scenario. All right, let's see if there's... So the dependent variable always depends upon what value is chosen for the independent variable. For instance, if I go to the gas station, what I pay at the pump is my y variable. It depends upon how much gas I put in the car, right? 5 different people can show up at the gas pump and put in different amounts into their car, right? All right? And so the cost that each of us pays depends upon how much each of us puts into the car. Does that help? Does that make sense? Okay, so gallons is my independent variable. Cost is my dependent variable. The solution to an equation with 2 variables in an ordered pair that makes the equation true, there are an infinite number of solutions to this, right? Because I can put in an infinite number of x values in and get an infinite number based upon that back. So solutions can be found by substituting values for the independent variable x to find corresponding values of the dependent variable y. Okay? Am I talking too fast or going too fast for you? No? Okay. All right, so let's try to look at some questions here. All right. So question number 1, state whether y equals 40 is a solution to 25 equals y minus 5. Is that a solution? No, why not? Right. Okay, he said because 40 minus 5 is 35, not 25. So when I substitute in, it does not equal the solution. All right? Probably what I'm looking at, what is the solution for y? 30, right? And how would I go about solving that without just kind of looking at it? And what property could I use to solve for y? Addition, property of equality, right? What would I have to do to both sides? Add 5, right? So if I add 5 to both sides, I get 30y equals 30, right? So that's using some stuff there. All right, let's solve q minus 9 equals 15. What property do I want to use here? Addition, property of equality. What am I adding to? Both sides. Both sides, right? Because if you just tell me I'm adding 9 to 15, right, and I know you don't mean this, but basically all you're doing there is 15 plus 9, right? I have to add 9 to both sides, otherwise I don't cancel out the negative 9 on the left-hand side, and I still wind up with q minus 9 equals 24, and I'm no closer to the solution, and I've unbalanced the equation, okay? So that's why doing it to both sides and saying that we're doing it to both sides, we want to be very literal here, okay? That way we get q equals, what's 9, what do I get whenever I add 9 to both sides? We get q equals 24, we get c, great. Do we feel like we kind of understand this? Okay, can we do it with fractions? If I do it like here with number 4, what do I need to do to both sides? Subtract 1 over 15 from both sides. So what I'm getting is I'm getting 1/6 minus 1/15, right? Well, I don't have an answer yet, because what do I need to do with both sides? I need to get a common denominator. What's the common denominator? 30. What do I have to do to the left-hand side to get that? Multiply by what? Yeah, but I'm looking at the equation I've written down, Tiffany. The left-hand side is 1 over 6. So what do I have to multiply 1 over 6 by to get a denominator of 30? 5. Do I just, what? Okay, let's be more specific here. Do I just get to do that? All right, good. I need to multiply it by 5/5 or 5 over 5. That's going to give me 5 over 30 minus what? What do I have to multiply the right-hand side by? Over 2, all right, or 2 seconds. All right, it's going to give me 2/30ths. All right, keep in mind, do I subtract the denominators? No, so I just leave 30 down here. What's 5 minus 2? All right, now we have to reduce. 1/10, okay? So x equals d 1 over 10. We understand that process. Some of these may involve more steps, okay? Let's see, you guys are typically out of here at 9:48. We've taken up quite a bit of time here this morning. Do you guys feel like you understand this well enough to get started? Okay, if you're confident? Okay.